Hello everyone, this is Revathi working as an assistant professor in information technology from SNS College of Engineering. In my today lecture series, we are going to see about maximum flow graph in the iterative method. The maximum flow problem is a classical optimization problem in graph theory that involves finding the maximum amount of flow that can be sent through a network, pipes, channels, or other pathways subject to capacity constraints. The problem can be used to model a wide variety of real world situations such as transportation systems, communication networks, and resource allocation. In the maximum flow problem, we have a directed graph with a source S and a shrink node T, and each edge has a capacity that represents the maximum amount of flow that can be sent through it. The goal is to find the maximum amount of flow that can be sent from source to the source node S to the shrink node T while representing the capacity constraints on the edges. Let us see this maximum flow graph by our student activities. Thank you.
Hello everyone, I am Dinesh of second year IT in SNS College of Engineering. Today we are going about the max flow problem introduction. The max flow problem is a classic optimization problem in graph theory that involves finding the maximum amount of flows that can be sent through the network pipes, channels or other pathways subject to capacity constraints. The problem can be used to model a wide range of real-world substances such as transportation system, communication networks and resource allocation. Now let's see an real-time example. This is the weighted and directed graph. These are the six nodes S, A, B, C, E and D. This is the source node and the destination node, and we have one path. Now let's quick move on to the first node. The grapher are directed towards the path. Now we have to go through the first path. So from node S to A, the path goes, and by the way, A goes to the B, so the path moves on, and finally it will reach to the destination. Now let's see the weight of this graph. From source to 8 it takes 7, and from this node to that node it takes 5, and finally from this node to destination it takes 8. So now we need to block the shortest path. The shortest block is A to B. So now it gets blocked. Now the path between these two nodes are blocked. Now we can't use it anymore. Now besides that way, we need to look another way. So the path goes from source to B and to C, then finally it gets to the destination. For this part, let's check the weight. From source to that node, it takes 9, and from that node to this node, it takes 2, and at last from this node to destination, it takes 3. So we need to block the shortest path. As the shortest path in this is from this node to this node path, so it weight 2. Let's block the now we have two blocker paths. Beside this, we want to look the another way. Let's see how. Now let's check the another way. From source to A, so the path goes there and moves. Then next path from A to C, so the path goes that way. And it finally reaches the destination through the spot. 8 this graph. From source to 8 it takes 1, and from this node to that node it takes 5, and finally from that node to this node it takes 4. So we need to block the lowest path. As these two paths are get blocked. Now all the possible blocks are blocked. Now finally we will see the final path which is the maximum flow of this dam.